Wait, so are we doing that?
Yes, it is filming. Okay, welcome. We're gonna, one more time. Here we go. Today, we're gonna continue on with magnetism, which is what we're studying. As you'll notice on the board up here, continuation of the magnetic field. What did we learn about the magnetic field in yesterday's lab? What, Cooper?
Sometimes you can actually put things together that are magnetic and then pick up other metal things.
How did you turn a nail into a
What
magnet
we did
yesterday?
is when we got wire, copper wire, small wire.
Yeah.
We wrapped it 20 times around the nail.
Yes.
And then we got two sides and put it onto a battery on each side and
Yes.
held it there, and then went and picked it up, and it did get hot because the battery and all that's reacting to it.
It did get hot because of the energy
Yeah.
surging through the wire, that it turned all the little cells, all the little atoms in there, all the positives were on one side, all the negatives were on the other, which turned it into a magnet, huh? That's
And
right.
Sometimes we added more.
Yes, Kelby.
Yesterday, the metal's so hot it burned through the electrical wire.
It did. The energy got so hot. When did it get hotter? When it was more wraps, more batteries? When was it the hottest?
When it was connected to the battery.
So the whole time, the whole time. All right, so did it get hotter still, even whenever you wrapped it more times? So it even got hotter, the more wraps you meant. That means those atoms were going crazy, and they were really pounding out the energy. Energy makes heat. I am gonna pass out to you 3 sheets of paper, okay? Don't do anything with those sheets of paper until I get them all passed out.
Starbucks. Oh, wait.
Okay? Oh, I bent that.
That's small. You put
This will
Starbucks
work. What?
You Starbucks away.
No, you gotta keep your books out. We're gonna be looking in the books today, okay? Okay, who needs paper? Okay. Make sure you have 3 pieces, Kelby. I'm not sure I counted right.
Yes, I do.
Thank you. Okay. Here we go. Here we go. Everybody, who did not get paper? Did everybody get paper? Okay. All right. We are going to create a little flip book today. Okay? You guys have done these before, but they're a really great way to organize information. And we are going to organize all the information that we know about magnets today. Okay? We're going to read in the book, we're going to talk about what we did yesterday, and we're going to do something really cool. You see that crazy picture on the smartboard there?
Yeah.
It's a bowl of water. What possibly could I be doing with a bowl of water and magnets? What?
Putting a battery.
No, we're not putting a battery in the water, but that's a good idea.
See if a magnet can pick up paper clips through the water.
No, but that's a really good idea. Yes.
Sticking a magnet in the water to see if it'll still stick or if it'll still work.
Nope. You'll see. It's going to be really fun. Put your hands down. We'll talk a little bit, and then we're gonna do it. But first, you're gonna work on this. So, everybody, you know.
I think
What do you think? What do you think it is?
under there and trying to get it up and making waves in the water.
Oh, waves in the water.
No. Like pouring over.
Okay. Everybody, I'm going to take the dish of water off.
Oh, I thought that was just a drawing of it.
No, it's a dish of water. Now watch. I think you're going to take your paper, your 3 pieces of paper, and you're going to stack them like this. See how I'm staggering them? Let's see if this shows up.
Because that's it's white.
Okay, well, just a sec.
Now I see.
There is no problems with this.
Black.
Well, you can kind of see. See, 1, 2, 3. See how I stacked those? Okay, let's see if I can really get it close. And then you'll really be able to see. And I'm really gonna get a pencil so that you'll really be able to see. You see? Did that help out?
Can you turn off the light, see what it does?
Turn off the light. There.
That's better.
Okay.
Yeah.
See how the paper is staggered. So you're just going to stack your paper, you're going to stagger it. Brittany has it just perfect, just like this. See? 1, 2, 3.
Close it.
Just like that. Yes. Okay. Then I'll show you on the smart board and out here in front so you can see. You're going to fold it in half so that all the little, do you see how it's all staggered now?
Like this?
Yes.
Oh.
Okay, I'm going to show you out here now. So you've got your staggered paper like this. Does everybody see? Does everybody see this?
Yes.
Then you're going to fold it in half, just like this, so that all your little stacks are like stair steps. Does everybody see? Raise your hand if you're having trouble, and I will come around and help you. If you get it, in your box is a stapler, and you can staple your flip book. You were doing it just right. Just like that. Now staple. Andrea, you're doing it just right. You got it. Right. You did it. You had it. Out there? Is that where you want it?
We made these like they had like our names and then we had like stuff about it.
Now staple the top. You need no more than 3 staples. 2 staples will work, but no more than 3, okay? We don't need 27 staples across the front. Okay. Okay, did you get your stapled? Okay. All right. Did everybody get their book stapled? Also, in the middle of your table, I wonder if this.
Guys, listen.
Maybe the dark paper, we'll do a test, whether dark or light. We'll get it nice and still. Okay. For the lab, the mystery lab. Okay. Everybody's going to have a piece of paper like this, okay? And what I'm going to have you do is turn to your books, turn to page. I messed up the, turn to page 209, 209, and in your pods, in these scientific groups, you're going to read out loud amongst yourselves from page 209 to page 212. It's all about magnetism. So, when you're reading along and you see something super neat about magnets, and this is just a little spoiler alert, on page 210, on the margin, there's this cool little thing called Integrate Earth Science. You should probably read that. Hi, Mr. Minix. So, read about the Earth and its magnetic field, okay? 1 page in your flip book I want you to save for today's experiment. But the rest of the pages I want you to fill with things that happened yesterday with our electromagnets, So if you could put, in fact, everybody label their book magnetism. I'm a terrible speller. Let me see how to spell it. N-E-T-I-S-M. Magnetism. And you can put the definition right there. Any of your vocabulary words that you on this page, you might want to put electromagnets. Perhaps you can tell me on that page something that happened yesterday in the lab. So, everybody start now. Begin. Pick a person in your science pod and begin reading from page 209 to page 210. Section 3 about magnetism. Go ahead. Yeah, go ahead.
Did you use a magnet today? Did you use a magnet?
Ready, Courtney? Magnets. Did you use a magnet today? If you watch TV, listen to a CD, dried your hair with a hairdryer, or used a computer, the answer is yes. Magnets are a part of all these devices and many others. Magnets can exert or slap objects that are made from
You guys could also put
magnetic
poles. That's very
Magnets also
interesting.
exert
Forces.
force on magnets. It is the forces exerted by magnets which make them so useful.
Remember, say one page for today's experiment.
Every magnet has an input and its output.
Nice, Jordan.
It is the force
of a bar magnet itself.
Guys, in the center of your tables is markers so that you can illustrate things if you need to. Okay? Illustrate things too, Devin. You can draw pictures of anything you see. Look at here. Look at what happens whenever you put iron on a magnet. Isn't that cool? Maybe you should write that. That's called a magnetic field. Do you want to draw a picture of that in your book? You can draw pictures and write anything you want. Look. About magnets. What do you know about magnets? You don't want to read. Oh yeah, it's. I can show you. I have this stuff. You want me to show you how we made an electric magnet? Okay.
Magnetic field. If you hold two
Is Devin the only one
like
who's gone
holding two magnets
yesterday?
near each other,
Yes.
you can feel them push each other apart. Even though they are not touching, they follow the electric force exert forces on each other even if they are not.
This is what we
This is because an electric charge is surrounded by an electric field that exerts a force on
No.
other electric charges. In a similar way, a magnet is surrounded by a magnetic field that exerts a force on other magnets. The magnetic field around a bar magnet is shown in figure 19. Iron films sprinkled around a bar magnet lined up to form a pattern.
Okay.
Hold this wire from magnetic field by
Wire. Get your hand up here. We need to
the direction of the magnetic field around a magnet. Figure 19 shows the magnetic field
A battery has voltage, right?
close
That
together
means it has energy inside of it. Yes.
and close to the bar magnet. The magnet's field is strongest.
No, it doesn't shock you. It
The
does
magnetic field lines are closer together where the magnetic field is stronger. What?
I just
Don't you agree?
If you hold them
Very
back,
much.
the
Snail.
paper clip will stick on the magnet or keep moving it for it not to push on the bed. Both parents and them are not white when decorate magnet champion. Only metal shackles hanging out each other.
That's not a right or wrong question. I'm asking you. Magnets, we're gonna add some energy. We're gonna watch. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14,
The wires and magnets, materials, magnets.
20. I just wrapped the wire around electricity travels through wires.
Such as electrons are
So see here. So now here's one side of the battery is positive. See how it says it?
Yeah.
Positive, and one side is negative. That's how electricity works. Positive and negative.
Miss, no, was magnetism just like the cup, like the heading, or was supposed to match the one?
You can write anything you want, and that's a good heading. That's, it can be just the heading, or it can be a definition. But you guys, I encourage you, Cooper, I love your illustration there. So here's the positive side. Okay, let's see. It turns it into a magnet, doesn't it? Yeah, it's warm. Colin got his so warm yesterday that it burned the electrician's heat. He didn't use electricians. What do you think of that? And what we learned yesterday, Devin, is that the more times you wrap that wire around that nail, the more paper clips.
The man ran up and permanent magnet. If you hold one pair,
And so,
one paper clip against another paper clip,
so that's what we learned
even if they
yesterday
are
about
chain
electromagnets. Okay? I turned the nail into a magnet by putting electricity on it.
They both
The electricity comes from the,
They
watch this.
They neither attract nor repel each other. Why do the paper clips stick to a bar magnet, but not to each other? And a paper clip,
When
the
you
magnet
have,
don't. They're made or
you guys can read, you saw this yesterday.
oriented in random direction as shown in figure 21. As a result, the magnetic field around the man cancels
See why they call it
is not surrounded by a magnetic field. Figure 21. Show that in a permanent magnet such as a hard magnet, most
when I
of the
let
men
go of one
are
side of the battery.
oriented in a single direction. As a result, the magnetic field around
Once the electricity's gone,
the other
what
men
happens?
cancel out. Instead, these are magnetic fields add
It's not a
together
magnet anymore, is it?
to form a stronger magnetic field.
So,
The magnetic field that surrounds the magnet is a combination of the magnetic field around the magnet.
well, I will show you in this. Yes.
Why are magnetic materials attracted to magnet?
Nice, that's awesome.
But if you think
That's awesome.
magnetic domain.
Oh, excellent, I'm so excited to know that you're gonna be here with me the whole time. You're making me so happy. Oh, excellent. Here we go. Okay, let's see how far everybody is.
Is nearby. As shown in figure 22. The nearby field
I love this. Nice. I see a lot of you are drawing the electromagnets that we made yesterday. That is awesome.
This causes Facebook to be attracted to the magnet because when we are magnets,
Oh, it's beautiful, Jordan. It's right up in front of you.
longer than I wanted to do because they're attached to the magnet.
Darian, I know you're a super artist. Why don't you draw some of these cool pictures that you're seeing in the book, like this? Yes. That is iron shavings in the north and south poles.
I don't get what we're spaghetti does.
Just tell me what you learned about electromagnets yesterday. Maybe you're going to want to write something like,
I just wrote what we did and how it happened.
that's great. That's exactly what I mean. Magnetic poles. Magnetic poles. Maybe you want to write about magnetic poles.
Isn't the electromagnet what we did yesterday?
Yes. No, magnetism is what we're talking about in total. That's just the heading. Electromagnets is what we made yesterday.
Where do we draw it?
Yeah, draw it. Tell me what you found out. Draw it and tell me what you found out.
Okay, done.
I did it on Friday.
Left one for the other.
Okay, great. Can I show yours? Hey, everybody look up. Cooper's gotten a good start on his. He's chosen to write about magnetic poles, electromagnets, magnet materials, and the Earth's magnetic field. Spoiler alert. And inside he is illustrating and writing little definitions. Okay? Do you have to have written exactly what Cooper has written about magnets? No.
Did you read the whole thing? Oh, you want to read it? Okay.
I want you guys to pay attention to the idea that magnets have and magnetic materials have north